Look at this question. You see, we have a list of numbers 27, 28, 29, 30, 31, 32, 33, right? Part 2 of this work. This is part 2. We're welcome back to part 2. Now, from the list of numbers, write down the multiple of 7. Which of these number is a multiple of 7? Multiple of 7 means like numbers like 7 times 1 is 7. So if you go back to this place, multiple of 7 will be question number 6. So when we say multiple of 7, okay, when we say multiples of 7, will be equal to what? Like 7 times 1 is 7, 14, 7 times 2 is 14, 7 times 3 is 21. These are all multiples of 7. 7 times 4 is 28. These are all multiples of 7. 7 times 5 is 35. These are all multiples of 7. 7 times 6 is 42. These are all multiples of 7. So when we go through the list of the numbers that are given to us, you see if any of these numbers we've highlighted, if it's in that list, then if it's in that list, then that number is the multiple of 7. I think 28 is in that list. So 28 is obviously a multiple of 7. So let's take a look at the list. We have 27, 28, 29, 30, 31, 32, 33. So the only multiple of 7 we have here is 28. The only multiple of 7 here is 28. So our answer goes back to 28. 28. So I circled the multiple of 7. So Roman figure 1. Here is Roman figure 1. Roman figure 1, the answer is equal to 28. That's multiple of 7 is 28. The next question is, I think it's cube number, Roman figure 2. So we should identify cube number from the new set of numbers. Cube numbers. Cube number. So we just write NO for numbers. So they say we should identify cube number, I think. So let's take a look at it again. Yeah, cube number. Cube number is, I've already explained cube numbers. 27 is a cube number. 28 is not 29, is not 30, is not 31, is not 32, is not 33, is not. So the only cube number is 27 in this regard. The only cube number is 27. Cube number equal to 27. So that's the answer to that question. Then we go to the next one. The next one is what number? What they want? Prime number? Is it prime number they want? Next question is prime number, right? Prime number is number that has only 2 factors, itself and 1. 1 and itself are the only 2 factors that a prime number has. So we look for any number that has such characteristics. We look for any number that has such characteristics, itself and 1 only, then that number will be our prime number. So take a look at 27. No, can be divided by 3, can be divided by 9. 28 can be divided by 4, can be divided by 7. 29, yes, 29 is a prime number, right? Only 1 and 29 can go to 29. 2 cannot go, 3 cannot go, and any other number cannot go. 30 has a lot of number that can divide 30. We have 5 can go, 6 can go, 10 can go, 50 can go, and so on and so forth. 31 is a prime number, right? Yeah. So we have 29, we have 31. 32 is not, 33 is not. So 29 and 31. So you write both of them for this question. So for prime number, we have 29. We have 29 and 31. So these are the 2 prime numbers in this question, for this question. Okay, let's see the next question quickly. Let's see for our next question. So this question actually focus on two, identifying prime number, cube number, and cube number, prime number, square number, and number identification. The next one is about temperature. And they are usually in paper 2 of IGCSE. Now, the temperature at 700, this is 2400 hours. This one is using 2400 hours timing. The temperature at 0700 is negative, that's 7 a.m. in the morning, is negative 3 degrees Celsius. This temperature is 11 degrees higher than the temperature at 1. This temperature is 11 degrees higher than the temperature at 100. Find the temperature at 1. So minus 3 is 11 degrees higher. So if minus 3 is higher, that means we're going to go backward. You understand? We're going to go backward because minus 3 degrees higher. For example, let's say you are in a country like Canada. If the temperature is minus 3 degrees higher than the temperature at a later time, that means the temperature at a later time is lesser. So if it's lesser, so we're going to like minus, we're going to say minus 3 minus 11. So we're going to say minus 3 minus 11. So for this question 7, we're going to say minus, because this minus 3 is higher than the other temperature. So minus 3 minus 11, that gives us minus 14 degrees Celsius. So at 1, you have minus 14 degrees Celsius. Because minus 14 is lesser than minus 3. Negative number, the bigger the lesser it is. For negative number, the bigger the number, the lesser it is. Minus 3 is bigger than minus 14 in negative numbers. Is that okay? So that's that for that question. Let's go to another question. Is it right the number 5,207 in figure? 5,207. 5 million. Question 8. 5 million. 5 million 200 and 7 0 0 7. This is what they want us to write. 5,207. Because it's million, you must have 7 digits. 1, 2, 3, 4, 5, 6, 7. You must have 7 digits. Not like this. Not 5,207. Not like this. This is no more a million. This is like 52,007. This one is like 52,007. 52,007. So for 5,207 is written like this. Now let's go to the next question. Okay, it says one day in Chamonix, the temperature at noon was 6 degrees. At midnight, the temperature was 11 degrees lower. The temperature was 11 degrees lower. Write down the temperature at midnight. So we're going to say 6 minus 11. These are easy. 6 minus 11. Because at midnight, the temperature was 11 degrees lower than 6. So when they say lower than 6, you say 6 minus 11. That will give you negative 5. That will give you negative 5. Is that okay? So I don't need to do this. let's go to the next question. Complete the list of factors of 36. Now they gave us 1, 2, and then all the way to the last one, 36 itself. Now let's complete the list of factors. Okay, because we've not done any example on factors, so we have to do this. We have to do this one, this example. Question number 10 or so. But I call this one number 9 because we jumped one question just now. Okay, the factor of 36, we're going to list the factors. Factors. So factor of 36 means any number that can go into 36 starting from 1. 1 can divide 36, so I write it without a remainder. 2 can divide 36 without a remainder, so I write it. 3 can go into 36 without a remainder, I write 3. 4 can 4 go? Yes. 36 divided by 4, you get 9. So 4 can go into 36 without a remainder. Can 5 go? No. 5 cannot go into 36 without a remainder. 6 can go. Yes, because 36 divided by 6, you get 6. So 6 can go without a remainder. Then can 7 go? No. Can 8 go? No. 8 cannot go into 36 without a remainder. Can 9 go? Yes. 36 divided by 9, you get 4. So 9 is a factor of 36. Can 10 go? No. Without a remainder? No. Can 11 go? No. Can 12 go? Yes. 12 can go. 36 divided by 12 is 3. 12 can go without a remainder. 30 go? No. Can 40 go? No. Can 50 go? No. Can 60 go? No. Can 17 go? No. Can 80 go? Yes. Half of the number must be able to go to the number. 80 can go into 36. After the half of the number, the next one is 36 itself, is the number itself. After half of the number, the next factor is the number itself. So if I ask you to list for 12, 1 can go into 12, 2 can go into 12, 2 is a factor, 3 is a factor of 12, 4 is a factor of 12, 6 is a factor of 12. 6 is half of 12. After 6, the next one is 12 itself. So they asked us to, they remember they listed this for us. Let me highlight the one they listed. They listed 1, they listed 2, and they listed the last one, which is 36. They want us to fill this number 3, 4, 6, 9, 12, and 18. So these are the factors they want us to include. Okay, we should include 3, 4, 6, 9, 12, and 18. So these are all factors of 36. So we'll go to the next question. Do you understand?
Yes.
Okay. Let's take the next question. Write 50,060 in West. It's just to be able to know how to pronounce it. And how to pronounce it is to count from right to left. 0, you count 1, 2, 3, you put comma here. So every other number, if it's 2 digits, you got like 15,060. So this is simply 50,060. Question number 10. $50,060. They want us to write in West. So I think no need for me to write, right? Just for you, I already mentioned 50,000 and then 60. 15,000 15,000 15,000 and 60. 50,000 and 60. Okay, 50,000 and 60. So this is it for this question. Let's move on. This one is pretty easy. This section finished. To finish the easy part, we have the medium one now, right? This is the medium question, and let's see the medium one. So write down the cube number that is greater than 50, but less than 100. The cube numbers greater than 50 and lesser than 100. So if you remember, I already wrote cube numbers before. So we scroll up. I think we scroll up. The one greater than 50 for cube numbers. Right? Look at the cube numbers. I've written them before. So let me highlight them with blue. This one is greater than 50. Okay, I think it's the only one. Because greater than 50 and less than 100 is the only one, 64. So you see, pretty easy. Some questions look as if they are tough, but they're not. They're not. It's just for you to have the guts to face them. So a number greater than 50, cube number greater than 50, but less than 100 is only 64. That's the answer to that question. So we go to another question. Write down a square number greater than 10. Write down a square number greater than 10. Just a square number, meaning 1. The mark is 1. You can see the mark is 1. So any square number greater than 10. Any square number greater than 10. Like 16, like 25, like 36. Anyone. So you just write any number. So let's go to the next question. Just write any number greater than 10. Any square number that is greater than 10. Like starting from 16, 4 square is 16. Or you can write 5 square, 25, 25 as your square number. Or you can write 49, which is 7 square, or 36, which is 6 square. So any of the number. Now let's see this one. I see this question a lot in paper 2. Let's take a look at this one. You have 3.565 root 96, 8 root 7 root 12. From the list, write down a number that is a multiple of 3. A number that is a multiple of 3. 12 is one of them. Okay. 12 is a multiple of 3. Let's find out the square root of 196. What number do you get? If you say the square root of 196, what number do you get? Daniel, I'm waiting for you. Okay, it's 14. 14 is not a multiple of 3. So this number is not. 8 is not. 7 is not. So the only answer to the first one is 12. Multiple of 3 is 12. So our answer here is 12. The first one. Question number 12. So multiple of 3, I'll write M of 3 as abbreviation. It means multiple of 3. Multiple of 3 equal to 12. From the list of numbers, 12 is the only multiple of 3. 12 is the only multiple of 3. Now let's Let's see the next question. Also, a cube number. Which of these is a cube number? Cube number. None, right? Yeah, 8. 8 is a cube number. Why? Because 2 times 2 times 2 is 8. Okay? 2 to the power of 3. 2 to the power of 3 is 8. So 8 is a cube number. So we write cube number, C number. When I write C number, I mean cube number. Cube number equal to 8 from the list of numbers. This is Roman figure 1. This is Roman figure 2. Okay, now let's go to Roman figure 3. What did the question say we should do? It say find the prime number. Yeah, 5 is a prime number. 40 is not. You know this number means 14. They just put this to confuse you. This root, square root 196, it means 14. 1 4 actually. So it's not. 8 is not a prime number. Root 7 is not a prime number. 12 is not a prime number. Decimal numbers are not prime numbers. So the only one is 5. 5 is a prime number. So we write prime number, P number equal to 5. P number equal to 5. P number equal to 5. After prime number, they ask you for irrational number. You know, if you study this chapter of number, you see rational and irrational number. Right? Irrational numbers are numbers that cannot be expressed as fraction. They cannot be expressed as fraction. Irrational numbers. They cannot be expressed as fraction, and they do not have a terminating decimal. Neither does it have a recurring decimal. So, irrational number. Let's check. 3.56 is a rational number, so it's not irrational. 5 is a rational number. This is a rational number. 8 is irrational. The only irrational number is root 7. Root 7. Yeah, root 7 is an irrational number. So the only irrational number is root 7. Now let's write irrational number. I number. I arrow number. Irrational numbers. Irrational numbers. The only irrational number is root 7. From this question, root 7. Root 7 is the only irrational number from the list of numbers. Okay? Are you there?
Yes, sir. Can I go and pray?
Yes. 5 minutes or 10 minutes?
10.
Okay. Paper 2 and paper 4. So this first part of the questions are for paper 2 for extended. Because as a science student, you are doing extended. Okay, now here is the question. Say the lowest temperature recorded at Scott Base in Antarctica is minus 57 degrees Celsius, and the highest temperature recorded at Scott Base is 63.8 degrees Celsius, more than this 63.8 degree more than this negative 57, right? You say, what is the highest temperature recorded in Scott Base? So what we're going to do, we're going to say minus 57 plus 63.8. Minus 57 point, minus 57 plus Question number 13. So we have minus 57 plus 63.8, right? Plus 63.8. That will give you 6.8 degree. Okay. Say the lowest temperature recorded at skull base in Antarctica is minus 57. The highest temperature recorded in skull base is 63.8 more than this. So it's just this number more than the first temperature. What's the highest temperature recorded at the skull base? Okay, so we've done that. Now let's go to the next question. You say write down a prime number between 50 and 60. A prime number between 50 and 60. Now 51, let's start from 51. 51 is not a prime number because 5 plus 1 is 6. 6 can be divided by 3. It means 51 can be divided by 3. 52 is even number, so it can be divided by 2. So 52 is out of it. 53, you say 5 plus 3 is 8, cannot be divided by 3. So I think 53 is a prime number, right? Yep. 53 is a prime number. Then 54 is not. 55 is not. 55 can be divided by 5. Can be divided by 11. 55 is not. 56 is not. Can be divided by 2. 57 is not. Because can be divided by 3. Because 5 plus 7 is 12. 12 can be divided by 3, and therefore 57 can be divided by 3. So 58 is not. 59 is 5 plus 9 is 14. 14 cannot be divided by 3. So I think 59 it's a prime number as well. So the only two prime numbers we have is 53 and 59. So the two prime numbers between 50 and 60, 53 and 59. And 59. Okay, these are the two prime numbers we have between 50 and 60. Now let's go to the next question quickly. The more questions we do, the better we understand the chapter. Calculate 12 2. What's this? An incomplete question? I think this question is not complete, or something is missing. Let's see the next question. They're supposed to give us a list of numbers and then they tell us what to calculate. Okay, so here is a list of numbers. You have 21, you have 2 over 3, you have root 13, you have 31, you have root 121. Root 121 is actually 11 because square root of 121 is 11. And then you have 51, you have 0.7. From this list, write down a prime number. We already know what prime numbers are. 21 is not a prime number, 2 over 3 is not a prime number, root 13 is not a prime number, 31 is a prime number, right? 31 is a prime number. This one is 11. 11 is a prime number, right? So root 121, the square root of 121 is 11. So 11 is a prime number. So we say 31 is a prime number, root 121 is a prime number, 51 is not a prime number, and 0.7 is not a prime number. So the only two prime numbers are 31 and root 121. So the only two prime numbers are 31 and root 121. So we have that question number 14. Question number 14, let's have question number 14. This one is so good. Question number 14, we say the prime numbers are 31, right? We say 31, and write and like this with a symbol. 31 and root 121. Why do we choose root 121? Because the square root of 121 is 11, and 11 is a prime number. So that makes it part of the answer, the solution. So let's go to the next question. Let's go to the next question. Question 15. Oh, we're still answering this. This is just part of the question, prime numbers. Let's see the other question, the sub question under this number. Is it right an irrational number? Root 30 is an irrational number. Okay, I think root 30 is the only 2 over 3 is a recurring decimal. It will give 0.6666. So 6 is a recurring decimal, it's a rational number. All recurring decimals are rational numbers. All terminating decimals are rational numbers. But root 30 is not a irrational number. So square root 30 is an irrational number. So we put that other root 30. So we say irrational from my figure 2. Other irrational number, I arrow numbers. I arrow irrational number. We talk about root 30. We say root 30 is an irrational number. Root 30 is an irrational number. Okay, we go to the next question. They say I think there are only 2 of it. Okay, only 2 of it. So we're done with that question. Let's go to the next question. Now it's a write down prime number between 20 and 30. So this one we can just say it verbally. We don't need to write it down. Prime number between 20 and 20. So we'll go through the numbers starting from 21 to 29. So 21 is not a prime number because it has factors like 3 and 7. 22 is not. 23 it's a prime number. Yeah. 23 is a prime number, so we take note of that. 24 is not. 25 is not. 26 is not. 27 is not because it can be divided by 3. 28 is not. 29, yeah, 29 is a prime number. So our 2 prime numbers between 20 and 30 are 23 and 29. 23 and 29. So we said no need to write it down. We can just move on, right? 23 and 29, and only 2 prime numbers. Let's go to the next question. Say work out. Okay. Say work out the difference between the 2 prime numbers in the list above. The difference between the 2 prime numbers. So we're going to find 2 prime numbers from here. We're going to subtract the small prime number away from the big prime numbers. The big prime numbers. So let's find 70 is a prime number, right? We take note of that. 70 is a prime number. The next prime number is 39 is not. It's 41, right? 41 is a prime number. So you got to say 41 minus 17 because they say work out the difference between the 2 prime numbers. So 41 minus this question you say 41 minus 17. What do you get? 41 minus 17. Is it 22? The answer should be 22. Is it 24? Okay, 24. Okay, so that's that. Let's move on. I think we go to the hard one now because there are 3 levels. Okay, but these are all past exam paper questions. These are all past paper questions. Now let's go to the hard one. Now for the hard level questions from IGCSE, say the hard question level is say explain why root 3 is irrational number. Why is root 3 irrational number? Why is root 3 an irrational number? Root 3 is an irrational number because when you find the square root of 3, you're going to have decimals that are not repeating themselves, neither are they terminating themselves. Then the decimal is going to continue, it's not going to terminate. It will only stop after like 8 or 9 digits because your calculator memory is programmable to 8 or 9 digits. Okay, so but however, this number, if you continue to do long division, the number is going to continue, it's not going to stop. Okay, so root 3 is an irrational number because it does not have a recurring decimal, neither does it have a terminating decimal. So for any decimal to be rational, the decimal must be a terminating decimal or must be a recurring decimal. Okay, so that answers that. Let's go to the next question. Okay, question 2 says 1, 2, 3, 5, 7 are all common factors of two numbers. Write down the digits that the two numbers must end in. 1, 2, 3, 5, and 7 all are all factors of two numbers. Right? Are all factors of two numbers. They write down the digit that the two numbers must end in. Okay, let's try. Which two numbers we should have all these as their factors? Which two numbers? You think which number one can go into, 2 can go into? Okay, 3 can go into. Could be 12 now, but the moment you say 5 can go into it, 12 can no longer be the number. Okay, 12 can no longer be the number. 50 can no longer be the number because 2 cannot go into 15. Okay, 80 cannot be the number because 3 can go into 18, but 5 cannot go into 18. 20 cannot, 5 can go into 20, but 3 cannot. Okay, at the moment 30, at the moment 30, because 3 can go, 5 can go, but 7 cannot go. Because 7 cannot go into 30, so 30 is not going to be one of those factors. So which number 3, 5, and 7 can go, and at the same time 2 can go? 35, no, because 3 cannot go. 3 and 2 cannot go into 35. 42, 2, 3, and 7 can go, but 5 cannot go. 50, 5 can go, 2 can go, 3 and 7 cannot go. Okay, can we multiply all the numbers first and see what we get? 1 times 2, 2 times 3, 6, 6 times 5, 30, 30 times 7, 210. So 210 is one of the factors. Because all these numbers can go into 210. Yeah, 210 is one of the factors. And then the second one, you can just double the number, like 420. So you say, write down the digit that the two numbers must end in. 0. 0 is the digit. 0 is the digit that the two numbers must end in. Is that okay? So one of the simple way to get this is to multiply all the factors. So simply multiply all the factors by saying 1 times 2 times 3, which gives us 6, times 5, which gives us 30, and then times 7. 30 times 7, this gives us 210. So 210 is the first number that all of these numbers can go into. It's the first number that all of these numbers. So you can as well double it. Double of this gives us 420. 420. You can begin to add 210 to the number. So the next one will be 630. 630 is the next one. So you add 210 to every number. 630, 840, like that. Okay, these are the factors, but they only want the first two. They say we should tell which digits the two factors ends with. Which digit is digit 0? So the two factors end with the digit 0. The two factors end with digit 0. Can you hear me?
Yeah.
Okay. So the two factors end with digit 0. because the two factor in this question or in this regard is this and this first two. Let's say this 210 and 420. So these are the first two factors in this regard, and they both end with digit 0. So that's that for that question. Now let's move to the next question. Write down an irrational number. Can you tell me any irrational number? Root 2. Root 2 is an irrational number. Root 3. Root 3 is an irrational number. 22 over 7, you know pi. 22 over 7 is an irrational number. Root 5 is an irrational number. Root 7 is an irrational number. Root 11. Not root 9, because root 9 gives you 3. Root 11, root 13. You see all prime numbers, just put roots on top of prime numbers, you get irrational number. That's the trick. Just put square root on top of every prime number, you get an irrational number. Is that okay? Is that okay?
Yes.
Okay, so that's it. Let's go to the next question. Insert one pair of brackets to make this calculation correct. This question is not correct. I think they made a mistake. They did put the sign plus, minus, or equal to 49 or equal to. Maybe they want to say this plus this or minus this equal to this. They did put the sign here for us to do this. Is that okay? So there's something wrong with this one. Next question. Okay, question 5A. This is purely IGCSE paper question. Tom is tiling a wall. He needs to buy at least 100 ties. The ties are sold in large packs and small packs. The large pack, 40 ties, is $18. Small pack, 28 ties, is $14. Special offer. 25% reduction when you buy 3 or more large packs. Work out the cheapest cost for Tom to buy the packs of ties he needs. First of all, you must know how many he needs. He needs 100 ties, right? So he will get if you buy the large one, you will get 40 in each of them, and you'll be getting 25% discount for if you buy 3 or more. So if you take 3 or more, let's say you take 3, 18 times 3 will give you what? 18 times 3 is what? Is it 54? 50 something, right? 18, 1 8, 1 8. 1 8 times 3, 54. Now 54, find 25% of 54. 25% means multiply by 0.25. 54 times 0.25, you get 13 point. So you will be buying, you get a discount of 30.5. So 54 minus 30.5. Okay, I think we should do it right, rather than, because this one is beyond you would have spent $40 for that special offer, and then you've already bought 54 from the large ones. No, each large one is 40, 40, 40. So you'd have had 120 ties, even more than, I would have spent $40.50. Okay, let's buy the small one. Let's assume we are buying only small one. 100 divided by 28. Let me know how many of the small one we need to buy. We need to buy 3.5. Okay, let's say we buy for small one 28, that's 56, right? No, that's 56, right? It's less than 60. Okay, let's buy 2 of this 80 and 1 of this. No, if you get two of these, you will not get discount. They say you must buy 3 or more large one in order to get the special discount. If you buy 3, it's already more. You spend $40 plus. Okay, let's say if we buy 2 of these and one of these is still not up to 100. Let's just buy 3 of small one. 50, 28 times 3 is what? 84. Okay, 28 times 4 is what? 28 times 4. 112. Okay, so the money is $14. So we say $14 versus 16. So we say $40 times 4. $40 times 4. We spend 56. Times 4. We would have spent $56. Would have spent $56. So this is not economical for us. This is not economical for us. So it's better because this one is 28 ties. 28 ties times 4 pack of it. If you multiply by 4 pack, you get 100. Multiply by 4 pack, that will give us 112 ties. 112 ties. And each 28, this one would have given us 112 ties. And each 28, each small pack, that's 28, costs $40. So if you say $40 times the 4 pack you bought, that you would have spent $56. So this is not economical. I think we go for 3 large ones. So the 3 large one will get a discount of 25%. So the 3 large one, each of them is 40 ties. We get 40 ties times 3. 40 ties in each of the large one. And if you buy 3 of it, you get 120 ties. Right? You need 100, but you just have extra 20. But we are considering the economical, the money you spend. So we buy 3. If we multiply by 3, we get 120 ties. And each of this one costs us, each one is going to cost us $18. So if I say 18 multiplied by 3, this 80, because we are buying 3 packs, $80, because each of this one is $80. $80 times 3, because we are buying 3 packs, that would have given us $56. That would have given us $56, which is equivalent to what you spend if you buy 3 small one, 4 pack of it. However, why this one is better, because they say they will give us, if you buy large one, 3 or more, you are equivalent to 25% discount. So let's find 25% of this, which means 100. If you can, there are 2 ways of doing that. 100 minus 25 would be 75. 100 minus 25 would be 75. So I can find 75% of this amount. So this will be 75. So I can find 75% of 56. So 56 times multiplied by 0.75. 75% is 0.75. So 56, sorry, here is 56, 56 times 0.75, that will give us what? 56 times 40.42. So we would have spent $42. So it's more economical. You save more money if you buy 3 large ones. If you buy 3 large pack of it. So this is more economical. So rather than buying 4 small pack of ties and you go to spend $56, you can buy 3 large ones and you get 25% discount, and then you end up spending $42. So and you have extra ties, about 20 ties left out of the 100 that you needed. So you see, so it's better to buy the large ones. Okay, so I think this is for this question. So you spend $42 here. You write $42 here as economical amount to spend. Now another question, 5B. The one we did just now was 5A. So there's another question, 5B. The 5B is Tom is also tiling a floor. Just now he tiled a wall, maybe toilet wall. Now Tom has decided to also tile a floor. The floor is a rectangle with length 600 centimeter and width 240 centimeter. Each tile is a square with size 40 centimeter. So each tile is a square with size. So first and foremost, each tile is a square of 40 by 40. So 40 by 40. So first of all, I'm going to multiply 600 times so that we know the square centimeter of the floor. Let's know the square centimeter. See, these are applicable maths. Now, if you know this type of maths, you can be a civil engineer, you can be a technician, a plumber, whatever, all these things. So first of all, let's know the dimension of the floor in centimeter, in square centimeter. So the dimension of the floor in square centimeter is equal to 600 multiplied by 240. So let's know the square centimeter multiplied by 240. 600 multiplied by 240, we get, what do you get? We get 144,000 centimeter square, or square centimeter. 144,000. This is area of the floor. Okay, the square centimeter of the area of the floor. And 40 by 40 will be what? So that we know how many 45 by 40 we're going to buy. So 40 multiplied by 40, you'll get 160, right? 160, and be 60,000. 40 multiplied by 40, 1,600, sorry. So each tile, the square distance is 1,600. So to know the number of tiles you're going to buy, you divide your floor by the area of the tile. Area of the floor divided by the area of the tile. Hello? So to know the number of tiles, number of tiles you're going to buy. So this is the area of tiles, area of each tile in square centimeter. This is the area of each tile, and this is the total floor area of the floor you're going to cover. So to know number of tiles, you will say number of tiles that you're going to buy, number of tiles we say this is equal to the square area, 144,000 centimeters square centimeter, 144,000 divided by 1,600, divide by the area of each tile, 1,600. So can you divide this and tell me? 144,000, 144, 3 zeros, divided by 1,600. So if you are buying large tiles, you're going to buy 90. If you are buying 40 by 40 for all, you're going to buy 90 tiles. Is that okay? Okay, but if you are going to use mixed tiles, then you're going to have something different. Number of tiles that will fit along the length is 600 divided by 40. Okay, he said each tie, each tie is a square with side 40 centimeter. Okay, the side is, so he divided the length, 600 divided by 40, we get 50, and 240 divided by 40, and then we'll get 6, and then you add it together, you get this. Okay, so I think this is the end of the question. Is there any other question? He said, give a reason why Tom's method is wrong. Because Tom is doing good. See what Tom did? Tom said, for us to be correct, you see what we did? This is what you're supposed to do. And this is what you need: 90 ties, not 21 ties. You need 90 ties. Okay? Not 21 ties. Tom, look at what Tom did. Tom was just saying the length divided by 40. He said, oh, the length of the floor is 600. So he took the 600 divided by 40, I got 15. And then this 50 doesn't make, he's supposed to multiply. If you use this method, you're supposed to say 50 times 6. He went to add them together, because this method is also correct if Tom has said 50 multiplied by 6, because we are talking about square area. You multiply area, you don't add area. Tom went to add. Okay, Tom went to add. So you don't add areas, you divide, you multiply area. So if you are using the length of the floor divided by length of the ties, you get 600 divided by 40, you get 15. Okay, fine. Now, number of ties that we fit to the width, you take the width of the floor divided by the length of the ties, the width of the ties. So 240 divided by this, you get 6. So the total number of ties you need or needed is not 50 plus 6, it's 50 plus 6, which will give you 90, which is what we got. So whether you did like Tom or you did like the way we did, you're supposed to get 90 ties. You're supposed to get 90 ties. Is that okay? Hello?
Yeah.
Are you here?
Yes.
Okay, we are going to stop. I think this is the end of the hard questions. I think so. Okay, there's the next question. We're stopping here because it's 7. So I prepare for break your fast. But let's just verbally go through this one. Let's just verbally.
Sir, can you send me the notes you wrote?
Okay.
On
Okay.
the whiteboard thing?
Okay, I will.
Thank you.
I will. So let's verbally 1 minute. If it's taking time, we just leave it. But let's just verbally go through this question and then we end it. A is a prime number. B is an even number. Then you have n, a square. A is a prime number. If you square a prime number, for example, 3 is a prime number. If you square 3, you get 9. Obviously, it's no longer a prime number. Another prime number is 2. If you square 2, you get 4. So if you are squaring prime number, you'll be getting what? You'll be getting square numbers. If you square 5 now, for example, 5. If you square 5, which is a prime number, if you square it, you get 25, which is a square number. So if you are squaring prime number, you'll be getting square numbers. Okay, so I know what this one is now. A square will be square number. AB, if you take a prime number times B was what? Even number. A prime number could be like 2 times an even number like 4. 2 times 4 you get 8. 2 times 5 you get 10. You'll be getting even number. This one will be even. AB will be even. A square will be square number. A square if you square A square will be square number. SQ number. A square will be square. Then AB will be even number. A times B will be even. Will result to even number. If you practically do this, you get even number. So let's quickly see what they want you to do. N equals to this plus. So if you add a square number, let's say 25 plus even number, let's say 10, you can get 35. you will get n to be, let's take another square number. Let's say 4. 4 plus even number, any even number could be 8. 4 plus 8 is 12. Okay, let's say square number like 25 plus even number like 10, that will be 35. We circle the correct statement about n. Could be odd or even number, always prime, always even, always odd. Could be odd or even number. I think this will be the correct statement. Could be odd or even number. Okay, that's the correct statement for n. So that's that for this. We finished the hard section. So today, if you look at the number, we did number 2 kits. We finished both the easy, the medium, and the hard one. So with this, I think any number, any question from IGCSE on numbers, you should be able to do. But for numbers, it doesn't end with just the one we've done. We can do a class on prime number, ACF, FCF, questions on this, set notation, Venn diagram. They are all on numbers. So the next one we'll take 1.2 to try to do all the questions. Okay, they brought the question from paper 2 and paper 4. All the questions are from both papers. They brought any number question from paper 2 and paper 4. So we finished 1.1 today. So the next class we'll go to do 1.2, which is set notation and Venn diagrams. And then 1.3 we have prime number, factors, HCF and LCM. So we're going to do a lot of it to finish it. Everything, it includes compound interest, simple interest. It's not just number as far. We finished number. The next one is set and this thing, We finished number itself. The next one, according to the arrangement of this book, is set notation and Venn diagram. That's the next one we're going to do. Is that okay?
Yeah.
Okay. So tomorrow we meet tomorrow. Okay.